The 20th term from the end of the progression 20, 19 1 by 4, 18 and half, 17 3 by 4, and so on up to minus 129 1 by 4 is. So let's identify the progression. Here you can see that the difference between these two numbers is minus 3 by 4, and also the difference between these two numbers 18 and half and 19 fourth is 18 half to 19 is half, and again here 1/4, so 3 by 4th, so minus 3 by 4, and here we can say that there is a common difference between the terms is equal to minus 3 by 4, and this sequence can also be written from the end as minus 129 1 by 4, and the next number can be minus 128 and half, and again and so on till 19 1 by 4 and 20. And here we can say that the common difference will be plus 3 by 4 because we are taking from the end. And here the first term a is equal to minus 129 1 by 4, and common difference d is equal to 3 by 4. And now the term 20th term from the end of this progression is 20th term from the beginning. And from the beginning we need to find the 20th term. That is nth term is nothing but a plus n minus 1 into d, since it is an arithmetic progression. So we can write a plus 19d, that is minus 129 1 by 4 plus 19 into the common difference is 3 by 4, that is minus 129 minus 1 by 4 plus 19 threes are 57 divided by 4, which is minus 129 minus 1 by 4 minus 1 by 4 plus 57 by 4 is, so we can write 56 divided by 4, that is minus 129 plus 14, that is minus 115. So minus 115 is the answer, which is option B. An urn contains 6 white ball, we can say 6 white balls and 9 black balls. Two successive draws of 4 balls are made without replacement. The probability that the first draw gives all white balls and the second draw gives all black balls. So first we have taken 4 balls and the probability that the first draw gives all white balls. So we can say 6C4, and the total probability, so total 6 plus 9 is 15 balls. So 15C4. And then since it is without replacement, now we have only 11 balls, of which only 4 to be selected, and the probability that all the balls are white, so white balls, sorry, black, so black balls are 9 here, because the first 6 balls of first 4 balls of white color, so none of the black ball is removed, so we have 9 black balls, we have to select 4. So 6C4 by 15C4 into 9C4 by 11C4 is the answer. On simplifying, we can get 6 factorial by 4 factorial into 2 factorial whole divided by 15 factorial by 11 factorial into 4 factorial into 9 factorial by 9 minus 4 5 factorial into 4 factorial divided by 11 factorial by 11 minus 4 7 factorial into 4 factorial, so that we can write here 6 factorial divided by 4 factorial into 2 factorial into 11 factorial into 4 factorial divided by 15 factorial into 9 factorial by 5 factorial into 4 factorial into 7 factorial into 4 factorial divided by 11 factorial. So let us simplify here. 11 factorial gets cancelled, and 1 4 factorial gets cancelled here, and again 1 4 factorial gets cancelled. So the remaining we can write it as 6 factorial we can add 6 into 5 factorial, so that these both gets cancelled. And again here 9 factorial into 7 factorial we can add 7 into 6 into 5 into 4 into 3 into 2 divided by, so 2 factorial is 2, 15 factorial we can add 15 into 14 into 13 into 12 into 11 into 10 into 9 factorial, and again the denominator here 5 factorial. That's all. So we can cancel again here 5 factorial and 9 factorial can get cancelled, and here 2 3 times, and again here 3 5 times, and here 7 2 times, and again here 2 3 times, and again this 5 gets cancelled. So 3 here 4 times, and again 4 and 4 get cancelled, and again here 3 into 2, this is a 5 times. So the numbers left here only in the numerator is 3, upon the denominator we have 13 into 11 into 5. So 13 3 divided by 13 11s are here 143 5 times, or 55 into 13 will give 715. So 3 upon 715 is the answer, which is option C. If y is equal to y of x is the solution curve of the differential equation x square minus 4 of dy minus y square minus 3y of dx is equal to 0, where x is greater than 2 and y at x is equal to 4 is 3 by 2, and the slope of the curve is never 0, that is dy by dx is not equals to 0, then the value of y at x is equal to 10 is. The given differential equation we can also write x square minus 4 of dy is equal to y square minus 3y of dx, or we can write dy upon y times of y minus 3 is equal to 1 upon x square minus 4 dx. Let us integrate on both the sides. On the left side we have the difference of y and y minus 3 is 3. So let us multiply and divide with the 3 here. On the right side we can write x square minus 2 square dx. So we can write 1 upon 3. The numerator 3 upon y of y minus 3 we can write 1 upon y minus, or 1 upon y minus 3 minus 1 upon y dy is equal to integral 1 upon x square minus a square. We have integration 1 upon 2a into log mod of x minus a upon x plus a. So we can add 1 upon 3 log mod of y minus 3 minus log of mod y is equal to 1 by 4 log mod of x minus 2 upon x plus 2 plus integral constant c. So we can simplify here 1 by 3 log mod of y minus 3 upon y is equal to 1 by 4 log mod of x minus 2 upon x plus 2 plus c, and it is given that at x is equal to 4 y value is 3 upon 2. Let us substitute here. So 1 by 3 log mod of 3 by 2 minus 3 upon 3 by 2 is equal to 1 by 4 log mod of 4 minus 2 upon 4 plus 2 plus c, or we can write 1 by 3 log mod of 3 by 2 minus 3 is minus 3 by 2 divided by 3 by 2 is equal to 1 by 4 log 4 minus 2 is 2 upon 6, that is 1 by 3 plus c. Or we can write 1 by 3 log 3 by 2 upon 3 by 2 is minus 1, mod is there, so log 1 is 0. So the left side is 0. So we can write 1 by 4 log of 1 by 3 is equal to minus c, or 1 by 4 log of 3 is equal to c, or we can say that c is equal to 1 by 4 log 3. And now substituting c is equal to 1 upon 4 log 3 in the general solution, so we'll get 1 by 3 log mod of y minus 3 upon y is equal to 1 by 4 log mod of x minus 2 upon x plus 2 plus 1 by 4 log 3. And now we need to find the value of y at x is equal to 10. So let us substitute 1 by 3 log mod of y minus 3 y minus 3 upon y, we can add 1 minus 3 by y is equal to 1 by 4 log 10 minus 2 8 upon 12 plus 1 by 4 log 3. Or we can also write 1 by 3 log of mod of 1 minus 3 by y is equal to 1 by 4 taken common, log 8 by 12 we can write 2 by 3, log a plus log b is log ab, so we can write here log 2. So 1 by 3, or we can write 3 by 4 log 2, or 1 minus 3 by y is equal to 2 to the power of log 2 to the power of 3 by 4 here, that is 2 power 3 is 8, 8 power 1 by 4. So 1 minus 3 upon y is equal to 8 to the power of 1 by 4, or further simplifying 1 minus 3 by y is equal to 8 power 1 by 4, or 3 by y is equal to 1 plus 8 power 1 by 4, or y by 3 is equal to 1 by 1 plus 8 power 1 by 4, or y is equal to 3 by 1 plus 8 to the power 1 by 4. So y at x is equal to 10 value is 3 divided by 1 plus 8 to the power 1 by 4 is the answer, which is option C. The integral x power 8 minus x square of dx upon x power 12 plus 3x power 6 plus 1 times tan inverse of x power 3 plus 1 upon x power 3. So here let us substitute or put tan inverse of x power 3 plus 1 by x power 3 is equal to t, and now differentiating with respect to 2x, we have 1 by 1 plus x square, that is x power 3 plus 1 by x power 3 whole square, into differentiation of x power 3 is 3x square, and differentiation of 1 by x power 3 is minus 3 divided by x power 4 dx is equal to dt. Upon simplifying, we can get 1 upon 1 plus x power 6 plus 1 by x power 6 plus 2 into 3x power 6 minus 3 divided by x power 4. X power 6 divided by x power 6 plus x power 12 plus 1 plus 2 into x power 6 into 3x power 6 minus 3 divided by x power 4. So we can get here x power 4 here x square times. So 3 into x power 8 minus 3x square, or 3 taken common, x power 8 minus x square divided by x power 12 plus 3 times of x power 6 plus 1 dx is equal to dt. So here we can clearly observe that x power 8 minus x square upon x power 12 plus 3x power 6 plus 1 dx is equal to dt. So dt by 3 we can write here, so that x power 8 minus x square dx upon x power 12 plus 3x power 6 plus 1 of dx is equal to dt divided by 3. So our integral we can write 1 upon 3 dt divided by t. Tan inverse of x power 3 plus 1 by x power 3 is 3 t. So we can add 1 by 3 log mod t plus c. That is 1 by 3 log t is nothing but tan inverse of x power 3 plus 1 by x power 3 plus c, or we can also write log mod of tan inverse x power 3 plus 1 by x power 3 whole power 1 by 3 plus c. So we can go with an option tan inverse of x power 3 plus 1 by x power 3 whole to the power 1 by 3 plus c is option B. So option B is the answer. Let g of x is equal to 3 times f of x upon 3 plus f of 3 minus x, and f double dash of x is greater than 0 for every x belongs to 0 to 3, and g is increasing, sorry, g is decreasing in 0 to alpha and increasing in alpha to 3. Then what is 8 times alpha? So let's differentiate this function. G dash of x is equal to 3 times f dash of x by 3 into differentiation of x by 3 is 1 by 3 plus differentiation of f of 3 minus x is f dash of 3 minus x into differentiation of 3 minus x is minus 1. So which we can write it as f dash of x by 3 minus f dash of 3 minus x. This is g dash of x. And now f double dash of x is greater than 0 for x belongs to 0 to 3, that is x lies between 0 and 3, and x upon 3 is lying between 0 to 1, and negative x lies between minus 3 to 0, and 3 minus x lies between 0 to 3. So here we can say that x upon 3 is smaller than x minus 3. So definitely, since f double dash of x is greater than 0, we can say that f dash of x is increasing. If f dash of x is increasing for x by 3 is less than x minus 3, so we can write f dash of x upon 3 is less than f dash of x minus 3, sorry, 3 minus x. So that implies f dash of x upon 3 minus f dash of 3 minus x is smaller than 0. So g dash of x is equal to f dash of x by 3 minus f dash of 3 minus x is smaller than 0. That is g dash of x is less than 0 for, and here we can say that x upon 3 is less than 3 minus x, that is x upon 3 plus x is less than 3, that is 4x upon 3 is less than 3, or x is less than 9 by 4. We can say for x is less than 9 by 4. So here g of x, g dash of x is less than 0 means g is decreasing. G is a function decreasing for 0 to 9 by 4, that is alpha is equal to, so we can write alpha is equal to 9 by 4, and then 8 times alpha is equal to 8 into 9 by 4, that is 18. So we can go with an option C. 18 is the answer. If limit extends to 0, 3 plus alpha sin x plus beta cos x plus log of 1 minus x upon 3 tan square x is equal to 1 upon 3, then 2 alpha minus beta is equal to. So let us multiply and divide with x square in the denominator, so that we can write limit extends to 0, 3 plus alpha sin x plus beta cos x plus log of 1 minus x upon x square or 3x square into 1 upon limit extends to 0 tan square x upon that is tan x upon x whole square. And we know that limit extends to 0, tan x upon x value is 1, and this limit value is equal to 1 upon 3. So we may cancel here 3 and 3 on both the sides, and also limit extends to 0, tan x upon x whole square value can be taken as this is 1 square in the denominator. So here we can write limit extends to 0, 3 plus alpha sin x plus beta cos x plus log of 1 minus x upon x square is equal to 1. And now since the limit value is defined, so let us apply the L'Hospital rule. To apply the L'Hospital rule, the numerator and denominator must be equal to 0, because when you apply x is equal to 0, denominator is 0. So numerator must be equal to 0 at x is equal to 0. So which implies 3 plus alpha sin 0, that is 0, plus beta into cos 0 is 1, plus log of 1 minus 0 is 1, which is 0. That is 3 plus beta, log 1 value is 0, so which is 0. So beta is equal to minus 3. So we got the value of beta is negative 3. And now let's apply the L'Hospital rule here. Limit extends to 0, differentiation of 3 is 0, plus alpha cos x minus beta sin x, and differentiation of log is 1 upon 1 minus x into differentiation of 1 minus x is minus 1 upon 2x is equal to 1. And now still we can see that the denominator is by substituting x is equal to 0. So to apply the L'Hospital rule or that limit to be defined, definitely the numerator of this function also must be equal to numerator must be equal to 0 at x is equal to 0. So that is alpha into cos 0 is 1 minus beta into sin 0 is 0 minus 1 upon 1 minus 0, which is equal to 0. That is alpha minus 1 is equal to 0, which implies alpha is equal to 1. So we got the value of alpha is 1 and beta is minus 3. And now to find 2 alpha minus beta, that is 2 into 1 minus of minus 3, which is equal to 2 plus 3, which is 5. So the answer is 5, option 1. Let f from r minus 1 by 2 to r, and g is a function defined from r minus 5 by 2 to r, defined by f of x is equal to 2x plus 3 upon 2x plus 1, where x cannot be equals to minus 1 by 2, and g of x is equal to mod x plus 1 upon 2x plus 5, where x is not equals to minus 5 upon 2. Then the domain of the function f circle g. And we know that the composite function f circle g is defined when g is a function defined from a to b and f is a function defined from b to c. Then there is a function composite function f circle g which is defined from a to c. So here the domain of the function g is r minus 5 by 2, and the codomain of the function g is r, and the domain of the function f is r minus, we are not supposed to take minus 1 by 2, so you can exclude minus 1 by 2 to define the function f, and then codomain is r. And now here we can say that f circle g is a composite function defined from r minus of minus 5 by 2 to r, so that we can say the domain of the function is r minus of minus 5 by 2, so which is option B. The position vectors of the vertices ABC of a triangle are given. A is given 2 comma minus 3 comma 3, that is 2i minus 3j plus 3k, and B is given 2i plus 2j plus 3k, that is 2 comma 2 comma 3, and C is given minus 1 comma 1 comma 3, that is minus I plus j plus 3k. And now if L is denoted the length of angular bisector AD, where D is on the line segment BC, then 2L square equals to. So let's find AB length. The length of AB is equal to, we can write under root of 0, that is 2 minus 2 whole square plus 2 minus 4 minus 3, that is 5 square 25, and again here 3 minus 3 is 0, so square root of 25 is 5, and the length of AC is equal to under root of 2 minus of minus 1, that is 3 square is 9, minus 3 minus 1, that is minus 4 whole square is 16, and 3 minus 3 is 0, so we are getting root 25, which is again 5. So the length of AB and length of AC both are same, so we can say that BD by DC is equal to AB by AC by internal angle bisector theorem, so which is equal to AB upon AC is equal to 1. So the ratio of BD is to DC is 1, so D is the midpoint. So we can say here 5 by 5, which is 1, so that we can say D is the midpoint. D is the midpoint of B and C. So we can write the midpoint is 2 minus 1 divided by 2, 2 plus 1 divided by 2, 3 plus 3 upon 2. So the D value is 1 by 2, 3 by 2, 6 by 2, that is 3. And now the length of AD is equal to distance 2 minus 1 by 2 whole square plus minus 3 by 2 whole square plus again 3 minus 3 whole square, which is equal to 2 to the 4 minus 1, 3 by 2 whole square is 9 by 4, and here minus 6 minus 3, that is minus 9 by 2 whole square is 81 by 4, and again plus 0, so which is equal to root of 90 divided by 4. 90 divided by 4 is nothing but 3 by 2 into root 10. So 3 by 2 root 10 is the value of L. So the 2L square value or L square is equal to 9 by 4 into 10. Our 2L square value is 9 by 2 into 10, that is 90 by 2 is 45. So the length is 45, that is which is option D. For A lies between 0 and 1, the value of integral 0 to pi 1 upon 1 minus 2a cos x plus a square dx is. So let us consider this is I, and by using the property 0 to a f of x dx is equal to 0 to a f of a minus x dx property. So we can write here I is equal to integral 0 to pi 1 upon 1 minus 2a cos of pi minus x plus a square dx, which is equal to 0 to pi 1 upon 1 plus 2a cos x, because cos pi minus theta is minus cos x, so we can write plus a square dx. Now let us consider this is 1 and say this is 2. Adding 1 and 2, we get 2i is equal to integral 0 to pi 1 upon 1 minus 2a cos x plus a square plus 1 upon 1 plus 2a cos x plus a square of dx. And in simplifying, we get 2i is equal to integral 0 to pi 1 plus 2a cos x plus a square plus 1 minus 2a cos x plus a square upon a plus b into a minus b, we can write a square plus 1 whole square minus 2a cos x whole square dx, which is equal to 0 to pi. So here we can cancel a square plus a square, that is 2 times of a square plus 1 upon a square plus 1 whole square minus 4a square cos square x dx. So we have I is equal to integral 0 to pi a square plus 1 upon a square plus 1 whole square minus 4a square cos square x dx, and we can say this is an even function, that is f of negative x is equal to f of x, that is cos of minus x is equal to cos x. So we can consider this function as even function, and we have the property integral 0 to 2a f of x dx is equal to 2 times integral 0 to a f of x dx, and hence we can write I is equal to 2 times integral 0 to pi by 2 a square plus 1 upon a square plus 1 whole square minus 4a square cos square, we can write it as 1 upon secant square x dx, and next we can simplify I is equal to 2 times integral 0 to pi by 2 a square plus 1 into secant square x divided by a square plus 1 whole square into secant square x minus 4a square dx, or this can also be written I is equal to 2 times integral 0 to pi by 2 a square plus 1 into secant square x divided by a square plus 1 into secant square, we can write 1 plus tan square x minus 4a square dx, that is I is equal to 2 times integral 0 to pi by 2 a square plus 1 of secant square x upon a square plus 1 of tan square x plus a square plus 1, sorry, this is whole square minus 4a square dx, and we know that a square plus 1 whole square minus 4a square is a square minus 1 whole square. So we can write integral 0 to pi by 2 a square plus 1 into secant square x upon a square plus 1 whole square into tan square x plus a square minus 1 whole square dx. Since a lies between 0 and 1, so let us consider a square minus 1 whole square instead of writing 1 minus a square whole square, and also 2 times of 0 to pi by 2 a square plus 1 of secant square x dx upon a square plus 1 whole square, let us take common, so we can write tan square x plus a square minus 1 upon a square plus 1 whole square. And now put tan x is equal to t, so that we have secant square x dx is equal to dt, and even the limits when x is equal to 0, t is equal to tan 0, it is 0, and when x is equal to pi by 2, t is equal to tan pi by 2, which is infinity. So we can add 2 times integral 0 to infinity, and here a square plus 1 one time gets cancelled, so 2 upon a square plus 1 into secant square x dx is dt upon t square plus a square minus 1 upon a square plus 1 whole square, that is 2 upon a square plus 1 into, and we know that integral 1 upon x square plus a square dx is equal to 1 by a tan inverse of x upon a plus c, So we can write 1 upon a, that is a square minus 1 by a square plus 1. So we can write in the numerator into tan inverse of x upon a, that is t into a square plus 1 upon a square minus 1 over the limits 0 to infinity, which is equal to 2 upon a square minus 1 into tan inverse of upper limit is infinity and minus tan inverse of the lower limit is 0. So we can add 2 upon a square minus 1 into tan inverse infinity is pi by 2 and minus tan inverse of 0 is 0. So we can add pi divided by a square minus, sorry, here is 1 minus a square I told. So let us change. So here it is 1 minus a square. So pi upon 1 minus a square is the answer. So which is option A. So I can go with an option A. Let E1 be the eccentricity of the hyperbola x square upon 16 minus y square upon 9 is equal to 1, and E2 be the eccentricity of the ellipse x square upon a square plus y square upon b square is equal to 1, where a is greater than b, which passes through the foci of the hyperbola. If E1 E2 is equal to 1, then the length of the chord of ellipse parallel to the x-axis and passing through 0 comma 2 is. So let us consider the hyperbola of the form x square by a1 square minus y square by b1 square is equal to 1. So that we have eccentricity E1 is equal to c1 upon a1, and we have the relation c1 square is equal to a1 square plus b1 square. So here a1 is equal to a1 square is 16. So 16 plus b1 square is 9. So c1 square is equal to 25. So c1 we can take it as a 5. So that foci of hyperbola can be taken as plus or minus c1 comma 0, that is plus or minus 5 comma 0, and which is given that the foci of the hyperbola, the ellipse is passing through. So ellipse is passing through the points plus or minus 5 comma 0. So we can consider that this ellipse is having where a is greater than b. So the point is 5 comma 0 and 0 comma minus 5 comma 0 are the vertices of an ellipse. So we can say a is equal to 5. So when a is equal to 5 and the eccentricity E2 is equal to, so we have the relation E1 E2 is equal to 1. So E1 is equal to, and we got E1 is equal to here C1 upon, that is 5 divided by a1 is equal to 4. So 5 by 4 into E2 is equal to 1. So E2 is equal to 4 upon 5, and which is equal to C upon A. So here A is equal to 5, so which implies that C is equal to 4. So the ellipse equation C square is equal to A square minus B square. So we can write 16 is equal to 25 minus B square, which implies B square is equal to 25 minus 16, that is 9. So B is equal to 3. So we can consider here the B value 0 comma 3, and this is 0 comma minus 3. So the ellipse equation, we can conclude the ellipse equation as x square upon a square, that is 25, plus y square upon b square is equal to 9 is equal to 1, and the length of the chord which is drawn parallel to the x-axis and passing through the point 0 comma 2. So passing through the point 0 comma 2, so we can draw a line parallel to it. which cuts the ellipse at the point. So let us substitute y is equal to 2 here. So we have x square by 25 plus y square, that is 4 divided by 9, is equal to 1. So x square upon 25 is equal to 1 minus 4 upon 9, that is 5 by 9, or x square is equal to 25 5 times 125 divided by 9. So which implies x is equal to plus or minus root of 25 is 5 root 5 divided by 3. Since the x coordinate is here 5 root 5, so we can say here this is 5 root 5 and here it is negative 5 root 5. So the length of the chord, therefore length of chord, we can write it as 2 times of x, that is 10 root 5 divided by 3. So 10 root 5 upon 3, which is option D. So we can go with an option D. Let the image of the point 1 comma 0 comma 7 in the line x upon 1 is equal to y minus 1 upon 2 is equal to z minus 3 upon 3 be the point alpha beta gamma. So let us consider the point P 1 comma 0 comma 7 and its image with respect to the line x upon 1 is equal to y minus 1 upon 2 is equal to z minus 2 upon 3 be the point say q alpha beta gamma. Let us draw the line which is perpendicular to the line. Let m be the foot of the perpendicular upon the line. So m is the point lying on the line and we can say the line PM is perpendicular to the given line, and the direction ratios of, let us consider general point on the line by taking lambda. X is equal to 1 lambda and here y minus 1 is equal to 2, y minus 1 is equal to 2 lambda, y is equal to 2 lambda plus 1 and z is equal to 3 lambda plus 2. So we may consider the direction ratios of the line joining P and M can be taken as lambda minus 1 direction ratios of the line joining PM can be taken as lambda minus 1 or 2 lambda plus 1 minus 0 and 3 lambda plus 2 and minus 7, that is we can write 3 lambda minus 5. And direction ratios of given line, direction ratios of given line can be taken as 1 comma 2 comma 3. And we know that if A1 B1 C1 A2 B2 C2 are the direction ratios of two given lines which are perpendicular, then we have the condition A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So here we can write, which implies lambda minus 1 times of 1, lambda minus 1 times of 1 plus 2 lambda plus 1 times of 2 and 3 lambda minus 5 times of 3 is equal to 0. Upon simplifying, we'll get lambda minus 1 plus 2 lambda plus, 4 lambda plus 2 plus 3, 3 is a 9 lambda minus 15 is equal to 0. So we may get 9 lambda plus 4 lambda 13 plus 1, that is 14 times lambda, and 2 minus 15 minus 13 minus 1, that is minus 14 is equal to 0, which implies lambda is equal to 1. So we may consider the point M, that is lambda comma 2 lambda plus 1 comma 3 lambda plus 2. So which implies M is the point 1 comma 2 ones are 2 plus 1, that is 3 comma 3 ones are 3 plus 2, that is 5. So 1 comma 3 comma 5 we can consider the point M, and Q is the point which is the where m is the midpoint. M is the midpoint of P and Q. So we can write 1 plus alpha upon 2 is equal to 1. Beta plus 0 upon 2 is equal to the y coordinate 3. And gamma plus 7 upon 2 is equal to the z coordinate is 5. So which implies alpha is equal to 2 minus 1, that is 1. Beta is equal to 6. And gamma is equal to 10 minus 7, that is 3. So we can consider the point Q as 1 comma 6 comma 3. Then we need to find which of the following points lies on the line passing through alpha, beta, gamma and making angles 2 pi by 3 and 3 pi by 4 with y axis and z axis respectively, and an acute angle with x axis. Let us consider L comma M comma N be the direction cosines of the line which is passing through alpha, beta, gamma and making angles like L is equal to, let us alpha be the acute angle and M is equal to cos of, and the given angle 2 pi by 3, and N is equal to cos 3 pi by 4. So we can write here M is equal to cos 2 pi by 3 value is 90 plus 120 degrees, 90 plus 30, that is sine 30 minus 1 by 2, and N is equal to cos 3 pi by 4, that is 90 plus 45, so minus 1 by root 2. And we have the relation L square plus M square plus N square is equal to 1. So L square plus 1 by 4 plus 1 by 2 is equal to 1. So L square is equal to 1 minus half minus 1 fourth is again 1 fourth, and L is equal to plus or minus 1 by 2. But since it is given that it is an acute angle with respect to with x axis, so we need to consider the positive angle. So L is equal to plus half. So we got L is equal to half, M is equal to minus 1 by 2 and N is equal to minus 1 by root 2. So the direction ratios we may consider L is to M is to N, which is equal to 1 upon 2 is to minus 1 upon 2 is to minus 1 by root 2, which can also be written as, so here minus into root 2 by root 2, which is 1 is to minus 1 is to minus root 2. So these are the direction ratios. And our line is passing through alpha, beta, gamma, and we can write x minus alpha upon 1 is equal to y minus beta upon minus 1 is equal to z minus gamma upon minus root 2, which implies x minus alpha is 1 upon 1 is equal to y minus 6 upon negative 1 is equal to z minus gamma is 3 upon minus root 2. And we can just check that among the four options, so option 3 will give the correct answer. So here when x is equal to 3, when x is equal to 3, 3 minus 1 upon 1 which is 2, and when y is equal to 4, so 4 minus 6, that is 4 minus 6 will be minus 2 upon 1. One second. Minus 2 upon minus 1, that is 2, and z is equal to 3 minus 2 root 2, we can substitute 3 minus 2 root 2 minus 3 upon minus root 2 is minus 2 root 2 by root 2 is plus 2. So we got 2, and here also 2, and here also plus 2. So we can confirm that option C satisfies. And which of the following point lies means we can say third point. This third option point may lies on the line passing through alpha, beta, gamma and having the direction cosines. Let capital R be the interior region between the lines 3x minus y plus 1 is equal to 0 and x plus 2y minus 5 is equal to 0 containing the origin. The set of all values of a for which the points a square comma a plus 1 lie in R. So it is given 3x minus y plus 1 is equal to 0, and there is one more line x plus 2y x plus 2y minus 5 is equal to 0. So both we need to find the set of all values of a for which this point a square comma a plus 1, say this point is p, and also containing the origin. And we know that when the point O and point P lying on the same side of the line, so we can substitute 3 into, let us consider the line 1, 3x minus y plus 1 is equal to 0. So we can substitute here the first point as L11, say 3 into 0 minus 0 plus 1 is equal to 1, which is positive, and the point L22, let us say the point this is L22, so 3 times of a square minus of a plus 1, which is 3a square minus of minus a minus 1 plus 1, that is 3 or a times of 3a minus 1. So L11, the condition is L11 into L22 must be positive when the 2 points are lying on the same side of the line. So that we can write 1 into a times of 3a minus 1 must be greater than 0. So we can say that when a is equal to 0 and a is equal to 1 by 3, so a must belongs to minus infinity comma 0 union 1 by 3 to infinity in the first case. And coming to the second case, now let's consider the second line x plus 2y minus 5 is equal to 0. So by substituting the first point, let us consider L11 by substituting 0, 0 plus 2 times of 0 minus 5, which is equal to minus 5, and L22 substituting the second point a square plus 2 times of a plus 1 minus 5, which is equal to a square plus 2a plus 2 minus 5 is minus 3, and the condition is L11 into L22 must be positive. So we can write negative 5 into a square plus 2a minus 3 must be positive, or we can write a square plus 2a minus 3 is negative. So by simplifying, we can write a square plus 3a minus 3 is negative, or a taken common a plus 3 minus 1 times of a plus 3 is less than 0. So we can write a plus 3 into a minus 1 is less than 0. So the solution will be lying between minus 3 and plus 1. So we can see that by wavy curve method we can consider the solution is a belongs to minus 3 to 1. Say this is second. So from 1 and 2, from 1 and 2 we can say that. So let us consider minus 3, and here it is 1 by 3 and 1 plus infinity minus infinity. So from the first one we can say that the region is from minus infinity to 0, and again from 1 by 3 to infinity, and in the second case we can say that minus 3 to 1, and we can find the common solution. The common solution can be taken as a belongs to -3 to 0 union 1 by 3 to 1. So -3 comma 0 union 1 by 3 comma 1, which is option B, option 2. So we can go with an option 2. Considering only the principal values of inverse trigonometric functions, the number of positive real values of x satisfying tan inverse x plus tan inverse of 2x is equal to pi by 4. And we know that tan inverse x plus tan inverse y is equal to tan inverse of x plus y upon 1 minus xy. So we can write tan inverse of x plus 2x upon 1 minus x into 2x, which is equal to pi by 4, or we can write x plus 2x is 3x upon 1 minus 2x square is equal to tan pi by 4, which is 1. That is 3x upon 1 minus 2x square is equal to 1. Or the cross multiplication we'll get 3x is equal to 1 minus 2x square. Or we can also write 2x square plus 3x minus 1 is equal to 0. On solving we get x is equal to minus 3 plus or minus under root b square minus 4 into 2 into minus 1, that is 8, divided by 2 into 2 4. So we can get minus 3 plus or minus root 17 upon 4, and since it is given positive real values of x, so we can consider only the value x is equal to minus 3 plus root 17 divided by 4. This gives the positive value. So minus 3 minus root 17 upon 4 is not allowed. So we can say only one solution. So we can go with an option B. If alpha comma beta are the roots of the equation, x square minus x minus 1 is equal to 0. So which implies we can write alpha square minus alpha minus 1 is equal to 0. That is alpha square is equal to 1 plus alpha, and also beta square minus beta minus 1 is equal to 0. We can say beta square is equal to 1 plus beta. And also given that Sn is equal to 2023 alpha power n plus 2024 beta to the power n. So let us consider Sn minus 1 plus Sn minus 2, which is equal to 2023 alpha to the power of n minus 1 plus 2024 beta to the power of n minus 1 plus Sn minus 2. We can write 2023 alpha to the power n minus 2 plus 2024 beta to the power of n minus 2. On simplifying, 2023 alpha to the power of n into alpha, or we can write n minus 2 into alpha plus 2024 beta to the power of n minus 2 into beta plus 2023 alpha power n minus 2 plus 2024 beta to the power of n minus 2. So 2023 alpha power n minus 2 we can take common. So from here, so we can write alpha plus 1, and again here 2024 beta to the power of n minus 2 taken common beta plus 1. So we know that alpha plus 1 is equal to alpha square. So we can write 2023 alpha power n minus 2 into alpha square plus 2024 beta to the power of n minus 2 into beta square, which is equal to 2023 alpha to the power of n plus 2024 beta to the power of n, which is nothing but your Sn. So finally we got it. Sn minus 1 plus Sn minus 2 is equal to Sn. And by substituting or put n is equal to 12, we have S12 minus 1 plus S12 minus 2 is equal to S12, that is S11 plus S10 is equal to S12. So we can go with an option S11 is equal S11 plus S12 is S10 is equal to S12, which is option D. Let A and B be two finite sets with m and n elements respectively. That is, number of elements in set A is equal to m and number of elements in set B is equal to n. The total number of subsets of A is number of subsets of A is 2 power m is 56 more than the total number of subsets of B, that is 2 to the power n. Or we can write 2 power n minus 2 power n is equal to 56. 56 we can write it as 64 minus 8. So 2 power m minus 2 power n is equal to 2 power 6 minus 2 power 3, which implies m is equal to 6 and n is equal to 3. So the point m comma n, we got it 6 comma 3. Now the distance of the point P m comma n from the point Q minus 2 comma minus 3 is, so distance between distance between 6 comma 3 point and minus 2 comma minus 3, say this is P and Q, is equal to under root of minus 2 minus x whole square, x2 minus x1 whole square plus y2 minus y1 whole square. So we can write under root of minus 2 minus 6 is minus 8 whole square, that is 64, and here it is minus 3 is minus 6 whole square, that is 36. So we can write 64 plus 36 is 100, which is equal to 10. So the distance of the point is, distance between the 2 points P and Q is 10 units. So we can go with an option D. Option D is the answer. The values of alpha for which 1 3 by 2, alpha plus 3 by 2, 1 by 3, alpha plus 1 by 3, 2 alpha plus 3, 3 alpha plus 1, 0, determinant is 0, which lies in the interval. So let's find the determinant. 1 times of 1 upon 3 into 0 is 0, minus alpha plus 1 by 3 into 3 alpha plus 1, minus 3 upon 2 times of 1 into 0, 0, minus alpha plus 1 by 3 into 2 alpha plus 3, and again plus alpha plus 3 upon 2 times of 1 into 3 alpha plus 1, 3 alpha plus 1, minus 1 by 3 into 2 alpha plus 3 is equal to 0. So let us simplify here. Minus of 3 alpha square plus alpha plus 1 by 3, minus of minus plus 3 by 2 times of 2 alpha square plus 2 upon 3 alpha plus 3 alpha plus 1 plus alpha plus 3 upon 2 times 3 alpha plus 1 minus 2 upon 3 alpha minus 1. So we can cancel here 1 and minus 1 and is equal to 0. So let's simplify here again. Minus 3 alpha square minus 2 alpha minus 1 by 3 plus 3 upon 2 into 2 alpha square is 3 alpha square, plus 3 upon 2 into 2 upon 3 alpha is alpha, plus 3 upon 2 into 3 alpha is 9 upon 2 alpha, and again here 3 upon 2, plus here 3 alpha minus 2 by 3 is 9 minus 2 7 by 3 alpha. So 7 by 3 alpha into alpha is 7 by 3 alpha square plus 7 by 2 alpha, which is equal to 0. So we have the alpha square terms are minus 3 plus 3 plus 7 by 3 alpha square, and alpha terms we have minus 2 plus 1 plus 9 by 2 plus 7 by 2, and the constants are minus 1 by 3 plus 3 by 2 is equal to 0, or we can write 7 upon 3 alpha square, and here we can write 9 plus 7 16 upon 2 is 8, 8 plus 1 9, 9 minus 2 is 7, this is alpha, and here 3 minus 1 2 minus 2 plus 9, that is 7 upon 6 is equal to 0, or here we can write 7 taken common, alpha square by 3 plus alpha plus 1 by 6 is equal to 0, or we can take 7 times of LCM is 6, we can add 2 alpha square plus 6 alpha plus 1 is equal to 0. So let us factorize this. Alpha is equal to minus b plus or minus under root b square minus 4 into 8 2 into 1, 4 into 2, that is 8, divided by 2 into 2 4, which is minus 6 plus or minus under root of 28 divided by 4, or we can write minus 6 plus root 28, we can write it as 2 root 7 by 4, or we can say here minus 3 plus or minus root 7 divided by 2. So alpha is equal to minus 3 plus root 7 upon 2, or minus 3 minus root 7 upon 2, and we know the approximate value of root 7 is 2.6 approximately, we can say. So we can write alpha is equal to minus 3 plus 2.6 upon 2, or minus 3 minus 2.6 upon 2, so which is equal to minus 2.6 minus 3 plus 2.6 is 0.4 upon 2, or minus 5.6 upon 2, or we can write minus 0.2 or minus 2.8. So minus 0.2 minus 2.8, which belongs to, we can say minus 2.8 and minus 0.2, 0, and this is 3. So we can say, we can conclude that these two values lies in the interval minus 3 to 0. So we can go with an option B. Let the position vectors of vertices ABC of a triangle are OA is equal to 2i plus 2j plus k, and OB is equal to I plus 2j plus 2k, and OC vector is equal to 2i plus j plus 2k respectively. And if L1, L2 and L3 be the lengths of perpendiculars drawn from the orthocenter of the triangle on the sides AB, BC and CA respectively, then find L1 square plus L2 square plus L3 square. So let us find the distances. AB is equal to OB minus OA, which is equal to 1 minus 2, that is minus I, 2 minus 2 that is 0 and 2 minus 1 that is 1k, so that the length will be mod of AB is equal to under root of minus 1 whole square is 1 plus 0 square plus 1 square root 2. And similarly BC is equal to OC vector minus OB vector, which is equal to I 1 minus 2 minus j and 0k, and you can see that the mod of BC also same as root 2. And coming to the CA OA minus OC, that is 0I plus j plus of minus k. Here also we can say the mod of CA is equal to root 2. So clearly we can say that triangle ABC is an equilateral triangle. If ABC is an equilateral triangle, we can say that we can conclude that orthocenter and centroid both are same. So we can find the centroid by using the formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So we can consider here the position vectors are given, so the points can be taken as 2 plus 1 plus 2 upon 3, comma 2 plus y coordinate 2 plus 2 plus 1 upon 3, 1 plus 2 plus 2 upon 3, which is equal to 5 by 3, 5 by 3, 5 by 3. And now the length of perpendicular, say the points A, B, C, the perpendicular, since it is an equilateral triangle, so D is the midpoint of B and C. So we can write the point D as D is the midpoint of B and C, which is equal to 1 plus 2 divided by 2, that is 3 by 2, 2 plus 1 divided by 2, that is 3 by 2, 2 plus 2 divided by 2, that is 2. So we can take the point D as 3 upon 2, 3 upon 2 and 2. And the centroid orthocenter from H to D, that is length L1, since it is an equilateral triangle, all lengths will be same. So we can define the distance between these 2 points H and D, that is 3 by 2, 3 upon 2 minus 5 by 3 whole square, plus again 3 upon 2 minus 5 by 3 whole square, plus 2 minus 5 upon 3 whole square under the root. And simplifying, you will get 9 minus 10 minus 1 by 6 whole square, that is 1 by 36. And here 9 minus again the same 1 by 36. And here 6 minus 5 1 upon 3 whole square, that is 1 by 9 under the root, which is equal to, so 1 upon 36, 1 upon 36, here you can multiply and divide with 4, so it is 4 by 36. So it is 6 upon 36 the root, which is 1 by root 6. So L1 value, L2 value and L3 value all are equal to 1 by root 6. So therefore our answer L1 square plus L2 square plus L3 square is equal to, so let me write here, L1 square plus L2 square plus L3 square, that is 1 by 6 plus 1 by 6 plus 1 by 6. So which is equal to 3 upon 6, that is 1 by 2. So the sum of the squares of the length from the orthocenter to the point D is nothing but 1 by 2. So we can just consider the answer is option D, fourth option. Let alpha is equal to 4 factorial whole factorial upon 4 factorial to the power 3 factorial, and beta is equal to 5 factorial whole factorial upon 5 factorial to the power 4 factorial. Then verify whether alpha and beta are natural numbers or not. And clearly alpha is equal to 4 factorial is 24, 24 factorial upon 4 factorial to the power 3 factorial is 6. And we can say that if suppose there are 24 letters in which 6 groups of 4 letters each, 4 letters are same, the number of arrangements can be given as the number of arrangements can be given by 24 factorial by 4 factorial into 4 factorial, that is 4 factorial whole power 6, which means that this alpha is the number of arrangements, which is a natural number of 24 and divided by 6 groups of 4, that is 6 fours are 24 it is getting. So we can say alpha is a natural number. And now coming to beta, beta is equal to 5 factorial, that is 120 whole factorial upon 5 factorial to the power 24. So here also we can use the same application. So let us assume that 120 letters are there in which 24 groups of 5 letters same. In such case the number of arrangements we can make as 120 factorial upon 5 factorial into 5 factorial, 24 times we'll consider, that is 5 factorial to the power 24, because 24 5s are 120. And so we can also say that it's number of arrangements, so beta is also natural number. So we can conclude that alpha is a natural number and beta is also a natural number, which is option A. Consider the function f from 0 comma 2 to r defined by f of x is equal to x upon 2 plus 2 upon x, and the function g of x is defined minimum of f of t when x lies between 0 and 1, and 3 upon 2 plus x when x lies between 1 and 2. So let us differentiate the function f dash of x is equal to 1 upon 2 minus 2 upon x square. On simplifying we can write x square minus 4 upon 2x square, and when x lies between 0 and 2, x square lies between 0 and 4. So we can write x square minus 2, x square minus 4 is less than minus 4 and 0. So we have the numerator part is negative and the denominator is positive. So we can consider f dash of x is equal to negative, which implies f is decreasing in its domain, that is 0 comma 2. And now g of x function we can write the minimum of the function f of t for x lies between 0 and 1. So we can consider x upon 2 plus 2 upon x for x lies between 0 and 1, and for 1 less than x less than 2 the function can be considered as 3 upon 2 plus x. And here the graph we can consider in 0 to 2. When x is equal to 2 we can say that 2 And here the graph we can consider from 0 to 1, and again from 1 to 2, the graph is given 3 upon 2, 3 upon 2 plus x. So when x is equal to 1, we can say that 1 by 2 plus 2 by 1, that is 5 by 2. And even here at x is equal to 1, 3 by 2 plus 1 will give the 5 by 2. So this is a linear equation, we can get a straight line. So here is a corner point. So that we can consider that from 0 to 2, the function g is continuous, but it is not differentiable at x is equal to 1, because there is a corner point where we can define infinite tangents, and hence differentiability is not defined at this point. So we can go with an option g is continuous but not differentiable. Option 4.
If 2 tan square theta minus 5 secant theta is equal to 1 has exactly 7 solutions in the interval 0 to n pi by 2 for the least value of n is a natural number, then find the sum k is equal to 1 to n k upon 2 power k. So given equation 2 tan square theta minus 5 secant theta is equal to 1 or minus 1 is equal to 0, and tan square theta we can write it as, we know that secant square theta minus tan square theta is 1. So tan square we can add secant square theta minus 1 minus 5 secant theta minus 1 is equal to 0. So we can simplify 2 secant square theta minus 5 secant theta, and here it is minus 2 minus 1 is minus 3 is equal to 0. This can be factorized 2 secant square theta minus 6 secant theta plus secant theta minus 3. 2 secant theta taken common, so secant theta minus 3 plus 1 times of secant theta minus 3 is equal to 0. So we can add 2 secant theta plus 1 into secant theta minus 3 is equal to 0. So we can add secant theta is equal to minus 1 by 2 and secant theta is equal to 3. Or we can add cos theta is equal to minus 2 or cos theta is equal to 1 by 3. So cos theta is equal to minus 1 by 2 is not possible. So cos theta is equal to 1 by 3 we may consider. Let's see the graph of cosine function. So here it is 0 and this is 1 pi by 2. This is 3 pi by 2 and here it is 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2 and this is 13 pi by 2 and here it is 15 pi by 2 and so on. And now the question cos theta is equal to 1 upon 3. So we can draw the line. So 1 by 3 will be here. Well, let us draw the line. Draw the line parallel to x-axis at the point 1 by 3, 0 comma 1 by 3 point. So we can say this line is representing y is equal to 1 by 3. And we can observe that cos theta is equal to 1 by 3 will cut the points at, so 1 point, The second point, 3, 4, 5, 6, 7, and it is given that it has exactly 7 solutions. So we can say 1, 2, 3, 4, 5, 6, 7 in the interval 0 to n pi by 2. So we can say this is 13 pi by 2. So we can define now. So 7 solutions in the interval 0 to 13 pi by 2. So this n is the smallest number now. So we can say n is equal to 13. Now let's consider summation. K is equal to 1 to n is 13 here. K divided by 2 power k, which is equal to 1 by 2 power 1 plus 2 by 2 power 2 plus 3 by 2 power 3 and so on. 12 divided by 2 power 12 plus 13 divided by 2 power 13. Let us consider to be s. Now let us multiply. 1 by 2s is equal to, we can write 1 by 2 times of s is equal to, so we can simplify and write here 1 by 2 in 1 by 2 into 1 by 2 is 1 by 2 square. Let us write here below 2 square, and 1 by 2 into 2 by 2 square will become 2 by 2 power 3, and 1 by 2 into 3 by 2 cube will become 3 by 2 power 4 and so on. 1 by 2 into 2 power 12 will become 12 by 2 power 13, and the last number 1 by 2 into 13 by 2 power 13. So let me write here 13 divided by 2 power 14 is equal to 1 by 2s. Now subtracting both, so we have s minus 1 by 2s is 1 by 2s is equal to 1 by 2, and these both 2 upon 2 square minus 1 upon 1 square is 1 by 2 square. 3 upon 2 cube minus 2 upon 2 cube is 1 by 2 cube and so on. 13 upon 2 power 13 minus 12 upon 2 power 13 is 1 upon 2 power 13 minus 13 divided by 2 power 14. So 1 by 2s is equal to, so it is in geometric progression. So we can write by using the formula Sn is equal to a into 1 minus r power n divided by 1 minus r, where r is less than 1. So here r is equal to 1 by 2. So a is equal to 1 by 2. 1 by 2 times 1 minus 1 by 2 whole power 13 divided by 1 minus 1 by 2 minus 13 divided by 2 power 14. So 1 by 2 s is equal to 1 by 2 divided by 1 by 2 into 2 power 13 minus 1 divided by 2 power 13 minus 13 divided by 2 power 14. So here we can cancel 1 by 2 1 by 2, and s is equal to 2 times of 2 power 13 minus 1 divided by 2 power 13 minus 13 divided by 2 power 14. So we can just multiply and divide with 2 here. So we'll get, so when you're multiplying 2 here, you'll be getting 2 power 13. So we can get 2 into 2 power 13 is 2 power 14 minus 2 and here it is minus 13 divided by 2 power 13, that is s is equal to 2 power 14 minus 15 divided by 2 power 13. So 1 upon 2 power 13, 2 power 14 minus 15 is the answer, which is option B.
If the solution curve of the differential equation dy by dx is equal to x plus y minus 2 upon x minus y, which is passing through 2 comma 1, is given by tan inverse of y minus 1 by x minus 1 minus 1 upon beta log of alpha plus y minus 1 whole square y minus 1 by x minus 1 whole square is equal to log mod of x minus 1. Then 5 times beta plus alpha is equal to, and it's very clear that the given differential equation is non-homogeneous because the degree in the numerator is not same. So you can consider it as a non-homogeneous differential equation. And the solution, the solving method is put capital X is equal to x minus h, or we can write x is equal to, we can write here x is equal to, small x is equal to capital X plus h, and small y is equal to capital Y plus k, so that dx is equal to d capital X and dh is 0, differentiation of h is 0, and here dy is equal to d capital Y, so that our differential equation we can write d capital Y by dx is equal to x is equal to x plus h plus y is equal to y capital Y plus k minus 2 upon x minus y, that is x plus h minus y minus k. So we can write dy by dx is equal to x plus y plus of h plus k minus 2 divided by, we can write x minus y plus of h minus k. And now to make this equation to get homogeneous differential equation, consider this h plus k minus 2 is equal to 0 and h minus k is equal to 0. So solving this both, when h is equal to k, so h plus h, here we can say that h is equal to k, substituting in the one, k plus k minus 2 is equal to 0, or 2k is equal to 2, which implies k is equal to 1, which also implies h is equal to 1. So we got h is equal to 1 and k is equal to 1, so that we can write small x is equal to capital X plus 1 and small y is equal to capital Y plus 1, or capital X is equal to x minus 1 and capital Y is equal to y minus 1. So that our differential equation can be written as dy by dx is equal to x plus y upon x minus y. So here we can say that this equation is homogeneous. Homogeneous differential equation. So the method is, solving method is, put y is equal to v capital X, so that dy by dx is equal to v plus x into dv by dx. So let us substitute here v plus x into dv by dx is equal to x plus y. So we can write here x plus vx upon x minus vx, that is v plus x into dv by dx is equal to x taken common 1 plus v upon x taken common 1 minus v. So we can cancel x and x. V plus x dv by dx is equal to 1 plus v upon 1 minus v. On simplification, x into dv by dx is equal to 1 plus v upon 1 minus v, that is x dv by dx is equal to 1 plus v minus v plus v square upon 1 minus v, or we can also write 1 minus v upon, here it is 1 plus v square, dv is equal to 1 upon x into dx. And now integrating on both the sides, 1 minus v upon 1 plus v square dv is equal to integral 1 upon x dx. And we can separate here integral 1 upon 1 plus v square into dv minus integral v upon 1 plus v square dv is equal to log mod x plus c. And now integration 1 upon 1 plus v square is tan inverse of v minus, and here let us multiply and divide with 2. So when we substitute 1 plus v square is equal to t, 1 plus v square is equal to t, so 2v into dv is equal to dt, or we can write, so here integral or 1 by 2 integral of dt divided by t, which is equal to log mod x plus c, or this can also be written tan inverse of v is nothing but y minus 1 by x minus 1, we can substitute directly, and minus 1 upon 2 integral 1 upon t is log mod t, t is nothing but 1 plus v square, 1 plus v square, v is nothing but y minus 1 by x minus 1 whole square, let us write directly, which is equal to log, here x is nothing but x minus 1 plus c. So to find the integral constant c, since it is given that the equation of the curve is passing through the point 2 comma 1, let us substitute x is equal to 2, y is equal to 1. So we have tan inverse of 1 minus 1, that is 0 upon 1 minus 1 by 2 log mod of 1 plus 1 minus 1, again 0 here, which is equal to log x minus 1, that is 2 minus 1 is log 1 plus c. So we have 0 is equal to log 1 0 plus c, which implies c is equal to 0, and hence we can conclude that tan inverse of y minus 1 upon x minus 1 minus 1 by 2 log mod of 1 plus y minus 1 upon x minus 1 whole square is equal to log of x minus 1 plus 0. So which is given in place of alpha and beta, here we can identify beta is equal to 2, and in place of alpha it is 1. So we can write alpha is equal to 1, beta is equal to 2, so that we required 5 times of beta plus alpha is equal to 5 times of 2 plus alpha is equal to 1, that is 10 plus 1 is 11. So 11 is the answer. The lines x minus 2 upon 2 is equal to y upon minus 2 is equal to z minus 7 upon 16, and x plus 3 upon 4 is equal to y plus 2 upon 3 is equal to z plus 2 upon 1 intersect at a point P. So let us consider is equal to lambda in the first line, and the second case is equal to mu, so that x minus 2 upon 2 is equal to lambda, which implies x is equal to 2 lambda plus 2, and similarly y upon minus 2 is equal to lambda, which implies y is equal to minus 2 lambda, and z minus 7 upon 16 is equal to lambda, which implies z is equal to 16 lambda plus 7. So we can consider here y is equal to minus 2 lambda, z is equal to 16 lambda plus 7, and x is equal to 2 lambda plus 2. Similarly, for the second line, we can write x plus 3 upon 4 is equal to mu, which implies x is equal to 4 mu minus 3, and y plus 2 upon 3 is equal to mu, which implies y is equal to 3 times of mu minus 2, and next z plus 2 upon 1 is equal to mu, which implies z is equal to mu minus 2. So we can write here x value is 4 mu minus 3 and y is equal to 3 mu minus 2 and z is equal to mu minus 2. Since they intersect at a point P, these two lines intersect at point P, so we can consider the x coordinates to be equal. That is 2 lambda plus 2 is equal to 4 times mu minus 3, and also which implies here 2 lambda minus 4 mu is equal to minus 3 minus 2, that is 5. And also y coordinates minus 2 lambda is equal to 16 3 mu 3 mu minus 2, or we can write it as minus 2 lambda minus 3 mu is equal to minus 2. And coming to the z coordinate, 16 lambda plus 7 is equal to mu minus 2, which implies 16 lambda minus mu is equal to minus 2 minus 1, that is minus 9. Now solving these both, adding this, we will be getting minus 4 minus 3, that is minus 7 mu is equal to minus 5 minus 2 is minus 7, so which implies mu is equal to 1. Substituting mu is equal to 1 here, we will get 16 lambda minus 1 is equal to minus 9. So lambda is equal to minus 9 plus 1, that is minus 8 upon 16, so which is 1 upon 2. So lambda is equal to minus 1 by 2 and mu is equal to 1. So we get the point x is equal to, let us substitute 4 mu minus 3. So therefore the coordinates are 4 times of mu minus 3, that is 4 into 1 minus 3, and y coordinate is 3 times 1 minus 2, and z coordinate is 1 minus 2, which is equal to point 4 minus 3, that is 1, 3 minus 2 is 1, 1 minus 2 is negative 1. So point we can say 1 comma 1 comma negative 1 is the point of intersection of the two lines. And now the lines intersecting at the point, and if the distance of the point P from the line, say we have another line, the distance of this point from the line is L given, then what is the 14 times of L square is, and the given line is passing through x minus or minus 1 upon 2, y minus 1 upon 3 is equal to z minus 1 upon 1. So we can consider that this line is passing through the point minus 1 comma 1 comma 1. Let us find the vector. Say this point is A, say this is M. PA vector we can write it as 1 minus of minus 1 I plus 1 minus 1 of j plus minus 1 of k, which is equal to 2I plus 0j plus of minus 2k. Or the length of the vector PA, we can write root of 2 square plus 0 square plus minus 2 whole square, which is equal to root of 4 plus 4, which is root 8. So we can say that the value of PA is root 8. And now the projection of the vector PA on the given line, whose direction ratios are 2, 3 and 1, which is given by mod of A dot B, that is PA dot 2i plus 3j plus k divided by mod of 2i plus 3j plus k, which is equal to, our vector PA is nothing but 2i plus 0j minus 2k dot 2i plus 3j plus k upon mod of 2i plus 3j plus k, which is equal to 4 and minus 2 divided by root of 2 square plus 3 square plus 1 square, which is 2 upon 4 plus 9 13 plus 1 root 14. So we got this value am is equal to 2 by root 14, and now therefore pm square is equal to pa square minus am square, which is root 8 whole square minus 2 by root 14 whole square, which is equal to 8 minus 4 by 14, that is 14 8s are 80 plus 40 32, 112 minus 4 divided by 14, which is 108 divided by 14. So pm square is nothing but L square. So we have this 14 L square is equal to 108 by 14, or 14 L square is equal to 108. So we can go with an answer 108 is the answer. Let capital A be a 2 by 2 real matrix and I be the identity matrix of order 2. If the roots of the equation A minus xi determinant is equal to 0, B minus 1 and 3, then the sum of the diagonal elements of the matrix A square is. So let A is equal to a 2 by 2 matrix A, B, C, D, and I is an identity matrix 1 0 0 1 of order 2, and determinant of A minus xi is equal to 0, that is A, B, C, D minus x into 1 0 0 1, which is equal to A minus x, B, C and D minus x, and its determinant is equal to 0, which implies A minus x into D minus x minus BC is equal to 0, that is AD minus x square, or this can also be written as x minus A into x minus D minus BC is equal to 0, that is x square minus A plus D of x minus AD or plus AD minus BC is equal to 0. So here we can say A plus D sum of the roots is equal to minus of minus A plus D, which is equal to A plus D, and given the roots are minus 1 and 3, so minus 1 plus 3 is equal to A plus D, that is A plus D is equal to 2, and product of the roots in the equation is equal to AD minus BC, and here we can write minus 1 into 3 is equal to AD minus BC. So AD minus BC is equal to minus 3, and now we need the sum of the diagonal elements of the matrix A square. So let us find A square is equal to ABCD multiplied with the matrix ABCD. You will get A square plus BC, and again here AB plus BD, and here AC plus DC, and here BC plus D square. and diagonal sum of the diagonal elements we can write sum of the diagonal elements is equal to a square plus bc plus bc plus d square, which is equal to a square plus d square plus 2 times of bc is equal to a square plus d square we can write a plus d whole square minus 2ad plus 2bc. A plus d value is 2, that is 2 square minus 2 taken common, ad minus bc. So we are getting 4 minus 2 times of ad minus bc is minus 3, that is 4 plus 6, which is equal to 10. So the answer is 10. Let the complex number alpha and 1 upon alpha bar lie on the circles z minus z naught mod square is equal to 4 and mod of z minus z naught square is equal to 16 respectively, where z naught is given 1 plus I. Then what is the value of 100 times mod alpha square? So here we can say that mod of z minus z naught is equal to r represents a circle with a center at point z naught and the radius is r. So here mod of, and also we know the concept, mod z square is equal to z into z bar. So we can write z minus z naught into z minus z naught bar is equal to 4, or we can write z minus z naught into z bar minus z naught bar is equal to 4. And since alpha lies in this circle, so let us substitute z is equal to alpha. So alpha minus z naught into alpha bar minus z naught bar is equal to 4, that is alpha into alpha bar minus alpha bar into z naught minus z naught bar into alpha plus z naught into z naught bar is equal to 4. So alpha into alpha bar is mod alpha square minus alpha bar into z naught minus alpha into z naught bar plus mod z naught into z naught bar is equal to mod z naught square. And since we know that z naught is equal to 1 plus I, then what is mod of z naught is equal to root of 1 square plus 1 square, that is root 2. So mod z naught square is equal to 2. So we can simplify and write here mod alpha square minus alpha bar into z naught minus alpha z naught bar plus 2 is equal to 4, or we can write mod alpha square minus alpha bar z naught minus alpha z naught bar plus is equal to 4 minus 2, that is 2. So let us consider this is an equation 1. And now alpha 1 upon alpha bar lies on the circle mod of z minus z naught square is equal to 16. So let us substitute z is equal to 1 upon alpha bar minus z naught whole square is equal to 16. We can write 1 upon alpha bar minus z naught into 1 upon alpha bar minus z naught whole bar is equal to 16, since mod z square is equal to z into z bar. So we can write 1 upon alpha bar minus z naught times 1 upon alpha minus z naught bar is equal to 16, or 1 minus alpha bar z naught by alpha bar into 1 minus alpha z naught bar upon alpha is equal to 16, or we can write 1 minus alpha bar z naught minus alpha z naught bar plus alpha into alpha bar and z naught into z naught bar upon alpha into alpha bar is equal to 16. So we can write here now 1 minus alpha bar z naught minus alpha z naught bar plus mod alpha square into mod z naught square is equal to 16 times alpha alpha bar is mod alpha square, or 1 minus alpha bar z naught minus alpha z naught bar, and here alpha mod alpha square and z naught square is 2, so we can write here 2 times of mod alpha square. So we can write here plus 2 times of mod alpha square is equal to 16 times of mod alpha square, or 1 minus alpha bar z naught minus alpha z naught bar is equal to 14 times of mod alpha square. And from the equation 1 we can write it as mod alpha square is equal to, we can write alpha bar z naught plus alpha z naught bar plus 2. So alpha 1 minus, we can write 1 minus alpha bar z naught plus alpha z naught bar is equal to 14 times of mod alpha square, or here we can write 1 minus of mod alpha square minus 2 is equal to 14 times mod alpha square, or 1 minus mod alpha square plus 2 is equal to 14 times mod alpha square, that is 15 times mod alpha square is equal to 3, or we can write 5 times mod alpha square is equal to 1, and since we required 100 times mod alpha square, so let us multiply with 20. 20 times 5 mod alpha square is equal to 1 into 20, so that is 100 times mod alpha square is equal to 20, so 20 is the answer. Let f of x is equal to 0 to x g of t into log to the base e 1 minus t upon 1 plus t dt, where g is a continuous odd function, and if integral minus pi by 2 to plus pi by 2 f of x plus x square cos x upon 1 plus e power x dx is pi upon alpha whole square minus alpha. And what is the value of alpha? Since g is an odd function, so we can write g of negative x is equal to minus g of x, and let us consider f of x is equal to integral 0 to x g of t log to the base e 1 minus t upon 1 plus t dt, and f of negative x is equal to 0 to negative x g of t into log to the base e 1 minus t upon 1 plus t dt, so that f of negative x is equal to 0 to negative x, and let us substitute t is equal to minus y, so that dt is equal to minus dy, and also when t is equal to 0 y is equal to 0, and when t is equal to negative x y is equal to plus x. So we can change the limits now, 0 to plus x g of negative y log to the base e 1 minus of minus y, that is 1 plus y divided by 1 minus y, dt is nothing but minus dy. So we can write f of negative x is equal to minus integral 0 to x g of minus y is nothing but minus g of x, so we can write it as minus g of y into log 1 upon 1 plus y upon 1 minus y, also we can write it as log 1 minus y upon 1 plus y to the power of minus 1 dy, are here integral 0 to x g of y into this minus 1 will come outside log 1 minus y upon 1 plus y dy. This is f of negative x, and it's very clear that minus 0 to x 0 of y log of 1 minus y divided by 1 plus y dy is same as f of x by changing the variable, so we can write minus f of x, so we can conclude that f is an odd function. So now minus pi by 2 to plus pi by 2 f of x plus x square cos x upon 1 plus e power x dx. Consider I is equal to, and now by using the property integral minus a to a f of x dx is equal to, so we can write f of integral minus a to a f of minus x dx, or a plus b, or we can also use the property integral a to b f of x dx is equal to f of a plus b minus x dx. Since here minus pi by 2 pi plus pi by 2 f of x, so we can write f of pi by 2 minus pi by 2 minus x, that is f of negative x dx. So we can also write I is equal to minus pi by 2 to plus pi by 2 f of negative x plus minus x whole square into cos of negative x divided by 1 plus e to the power negative x dx. That is I is equal to minus pi by 2 to plus pi by 2 f of negative x plus x square cos x into e power x divided by 1 plus e power x, because we can write e power negative x is nothing but 1 by e power x whole dx. Say this is 1, say this is 2. So by adding 1 and 2, so we get 2i is equal to minus pi by 2 to plus pi by 2. So here we can write f of x is negative, f of x is equal to minus f of minus x, that is f of x plus f of negative x is equal to 0. Since f is an odd function, we proved it, and hence we can write f of negative x plus f of negative x plus f of x can be 0, and so we can write x square cos x taken common 1 plus e power x divided by 1 plus e power x dx. So this is nothing but x square cos x. Now integrating, we have 2i is equal to, by using UV or FG rule, integral FG is equal to f integral g minus integral of f dash into integral of g. So we can write x square into integration of cos x is sin x over the limits minus pi by 2 to plus pi by 2 minus integral of f dash is 2x into integration of cos x is sin x dx over the limits minus pi by 2 to plus pi by 2. So we can write 2i is equal to, substituting here, pi square by 4 sine pi by 2 is 1 minus minus pi by 2 whole square into sine of minus pi by 2 is minus 1, and here minus 2 times of, and again applying the FG rule, so we can write x into integration of sin x is minus cos x, and minus integral of differentiation of x is 1 and integration of sin x is minus cos x, that is plus cos x here, minus pi by 2 to plus pi by 2, and here the limits minus pi by 2 to plus pi by 2. So we can write 2i is equal to, here pi square upon 4, and here it is minus of minus plus pi square upon 4, that is 2 times of pi square upon 4 minus 2 times of minus x cos x plus integration of cos x is sin x over the limits minus pi by 2 to plus pi by 2, or we can remove the 2 here. So we can write I is equal to pi square upon 4 minus, or minus of minus here, plus x cos x, and here it is minus sin x over the limits minus pi by 2 to plus pi by 2. Let us substitute it. I is equal to pi square upon 4 plus, so here pi by 2 cos of pi by 2 is 0, and lower limit is minus pi by 2 cos of minus pi by 2 is 0, and again the next one, sine of pi by 2 minus sine of minus pi by 2, which is equal to I is equal to pi square upon 4 plus 0. Sine pi by 2 is 1 and again minus 1, so minus 2. So we can say pi upon 2 whole square minus 2. So comparing with pi upon alpha whole square minus, we have pi upon 2 whole square minus 2. So we can say that alpha is equal to 2. The coefficient of x to the power 2012 in the expansion of 1 minus x whole to the power 2008 into 1 plus x square whole to the power 2007 is equal to. So we know that 1 minus x power 3 is equal to 1 minus x into 1 plus x square, or we can write 1 minus x power 3 upon 1 minus x is equal to 1 plus x square. So we can write here 1 minus x whole to the power 2008 into 1 minus x power 3 upon 1 minus x whole to the power 2007, which is equal to 1 minus x whole to the power 2008 upon 1 minus x whole to the power 2007 into 1 minus x power 3 whole to the power 2007, or we can write 1 minus x whole to the power 2008 minus 2007 is 1 into 1 minus x power 3 whole power 2007. So by using binomial theorem we can write 1 minus x into 2007 c naught into 1 minus 2007 c1 x to the power 3 plus 2007 c2 x to the power of 3 whole square minus and so on. We can write minus 2007 c 2007 x to the power of 3 x to the power of 3 whole to the power 2007. So to get the coefficient of x power 2012, so coefficient of x to the power 2012 is equal to, so 1 should be multiplied, 1 must be multiplied with the term with x power 2012, or the minus x must be multiplied with the coefficient here b times of x to the power 2011. And clearly we can say that all the powers of x here multiples of 3. Powers of x is either 0 or multiple of 3. So that we cannot find 2012. 2012 is not a multiple of 3, or 2011 is also not a multiple of 3. 2011, 2012, these both are not a multiples of 3, and hence we will not find either 2000 x power 2012 or x power 2011 in this expansion, and hence we can say that the coefficient of x power 2012 will be coefficient of x power 2012 in the expansion, in the given expansion will be 0, since there are no terms on this side. Consider a circle x minus alpha whole square plus y minus beta whole square is equal to 50. So we can say that the circle with the center is alpha comma beta and the radius is 50. We can write it as root 50 whole square or 5 root 2 whole square. So the radius can be taken as 5 root 2, and it is given that if the circle touches the line x plus y is equal to 0 at the point P, whose distance from origin whose distance from origin is 4 root 2, then what is the value of alpha plus beta whole square? And let us consider CB the center. So we have CP is equal to 5 root 2, that is the center to the point. The perpendicular distance we can write alpha plus beta upon root of 1 square plus 1 square is equal to 5 root 2, or alpha plus beta is equal to 5 root 2 into root 2, which is 5 2s are 10. So alpha mod of alpha plus beta is 10. Then alpha plus beta whole square is equal to 10 square, which is equal to 100. So we can go with an answer 100. If the area of the region ordered pairs x comma y such that 0 is less than or equals to y less than or equals to minimum among the 2x and 6x minus x square is given as a, then what is the value of 12a? So here y is greater than or equals to 0, and it is also given y less than or equals to minimum among the functions 2x and 6x minus x square. So let us sketch the graph. 6x minus x square we can write it as, so we have the points 0 and 6 as the critical points. We can consider 0 and 6 is the point, and since it is a negative coefficient x square, so the graph can be taken inverted. And now another line, 2x is y is equal to 2x is a straight line. So here is a graph, y is equal to x times of r 6x minus x square, and let us consider the straight line y is equal to 2x. It is passing through the origin, and let us find the point of intersection here. So this is P, y is equal to 2x, or y is equal to, or x is equal to y by 2. So we can substitute y is equal to 6x minus x square, that is y is equal to 3 times of 2x minus x square. Let us simplify, 2x is equal to x times of 6 minus x, or we can write 2 is equal to 6 minus x, or x is equal to 4. So we can consider the point x is equal to 4. If x is equal to 4, y is equal to 2x, that is 2 into 4, which is 8, 4 comma 8. So 4 comma 8 is the point, and the area of the region is, it's above y is greater than or equals to 0, then the positive y, and it is less than or equals to the minimum among these functions. So we can say from 0 to 4, from 0 to 4, the minimum is the straight line. So the required area A is equal to integral 0 to 4, the straight line y is equal to 2x, and from 4 to and from 4 to 6, minimum is the curve y is equal to 6x minus x square. We can write integral 4 to 6, the curve is 6x minus x square dx.
which is equal to 2 times of x square upon 2 over the limits 0 to 4, and again here 6x square by 2 minus x power 3 divided by 3 over the limits 4 to 6. Upon simplification, we'll get 4 square 16 minus 0, and here it is 3 times of 6 square minus 6 power 3 divided by 3, upper limit minus lower limit is 3 times of 4 square minus 4 power 3 divided by 3, which is equal to 16 plus, and here we can write 6 square common or 36 common, and 3 3s are 9 minus 6 is 3 divided by 3, and again minus here 4 square common, that is 16. 16 times of 3 3s are 9, 9 minus 4 is 5, 5 by 3, which is equal to 48 minus, so we can consider 16 plus 36 3 times 108 by 3 minus 16 5 times 80 by 3, which is equal to 16 plus 108 minus 80 is 28 divided by 3. 16 3s are 48 plus 28 divided by 3, which is equal to 76 by 3. So we got the value of A is 76 upon 3. A is equal to 76 upon 3. Now the required is 12 times A. 12 times A is equal to 12 into 76 by 3, that is 4 into 76. 280 plus 24, that is 304. So we can conclude that 12 times A is 304 is the answer. The mean and standard deviation of 15 observations were found to be 12 and 3 respectively. On rechecking, it was found that an observation was read as 10 in place of 12. If mu and sigma square denotes the mean and variance of the correct observations, then find 15 times mu plus mu square plus sigma square is equal to. So let us consider the mean as a mu dash is equal to 12, and variance, the standard deviation sigma dash is equal to 3 for n is equal to 15 for 15 observations. So we know the mean formula, summation xi divided by n is equal to 12, which implies summation xi divided by 15 is equal to 12. So we can write here summation xi is equal to 12 times 15, which is equal to 180. From the summation, we have to subtract, since 10 is a wrong observation and 12 is a correct observation. So we need to subtract 10 and add the 12, which is equal to 180 minus 10 plus 12, that is 182. Therefore, correct mean is equal to mu is equal to correct sum divided by the total number, that is 182 divided by 15. And now standard deviation or variance, for variance is equal to 3. So we have root of summation xi square divided by n minus summation x by n whole square, which is equal to 3. That is summation xi square divided by n minus, and summation x by n, that is a mean, is given 12, that is 12 square is equal to 9, squaring on both sides. So summation xi square divided by 15 minus 144 is equal to 9, or we can write summation xi square divided by 15 is equal to 144 plus 9, which is 153. Our summation xi square is equal to 153 into 15. The calculation you will get 2295. And now to find the correct standard deviation, so let us remove 10 square and add 12 square. So the correct sum of squares of deviations is equal to our old sum summation xi square. From here we have to subtract 10 square and we have to add 12 square. So which is equal to summation xi square is 222295. 2295 minus 100 plus 144. We will get the correct square sum of squares is 2339. And let us consider this sigma square as it is given variance. Sigma square is equal to summation xi square divided by n minus summation xi by n whole square, which is the correct sum squares. So we can add here 2339 divided by 15 minus, and the correct mean is nothing but 182 by 15. So we can add 182 by 15 whole square. So this is variance. Now the correct value, a required value, that is 15 times mu plus mu square plus sigma square is equal to 15 times mu value is 182 upon 15 and mu square value is 182 by 15 whole square plus sigma square is 2339 minus 15 minus 182 by 15 whole square. So we may cancel here 182 by 15 whole square. So 15 times 182 plus 2339, which is 2521, divided by 15, which is equal to 2521. So the required value is 2521 is the answer. If the sum of squares of all real values of alpha for which the lines 2x minus y plus 3 is equal to 0, 6x plus 3y plus 1 is equal to 0, and alpha x plus 2y minus 2 is equal to 0, do not form a triangle is P. For the greatest integer less than or equals to P is. So here for the first line equation, slope, let us take m1 is equal to minus 2 upon minus 1, which is equal to 2. Since we know that for the line equation ax plus by plus c is equal to 0, slope is minus a by b. And similarly for the second slope, m2 is equal to minus 6 upon minus 3, that is 2. Sorry, plus 3, it is minus 2. And coming to the third slope, m3 is equal to minus alpha upon 2. And here we can say that m1 and m2, they are not same. We cannot say that they are parallel. And for not forming a triangle, we have the two possible cases. Case 1, either alpha x plus 2y minus 2 is equal to 0 is concurrent with
any of the other lines, any of the other lines, that is 2x minus 5 plus 3 is equal to 0, or 6x plus 3y plus 1 is equal to 0. In such case, the area of triangle will become 0, that is there is no formation of area of triangle. And condition for this case is, we can use the determinant method for a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, and a3x plus b3y plus c3 is equal to 0 to become concurrent lines. We have a1 b1 c1, a2 b2 c2, a3 b3 c3 is 0, that is we can write 2 minus 1 3 6 3 and 1 alpha 2 and minus 2, which is equal to 0. So on simplifying, you can get 2 times of minus 6 minus 2, that is minus 8, plus 1 times of minus 12 minus alpha, plus 3 times of 12 minus 3 alpha is equal to 0. Or we can write minus 16 minus 12 minus alpha plus 12 threes are 36 minus 3 or 39 alpha is equal to 0. Or we can write 36 minus 60 20 20 minus 12 is 8, and here it is minus 10 alpha. Minus 10 alpha is equal to minus 8, so alpha is equal to 8 upon 10, which is equal to 4 upon 5. So in this case 1, we got alpha is equal to 4 upon 5. And coming to the second case, the case 2, either the slope of this line alpha x plus 2y minus 2 is equal to 0 must be equal to either of this, means minus alpha upon 2 is equal to minus 2, or minus alpha upon 2 is equal to plus 2. So in such case, we have minus alpha is equal to minus 4, that is alpha is equal to 4, or minus alpha is equal to 4, that is alpha is equal to minus 4. So the three possible cases, three possible values of alpha we got it. Alpha is equal to 4, alpha is equal to minus 4, and alpha is equal to 4 by 5. And the question is about the sum of squares of all real values. All these are real values. So sum of squares alpha is equal to, possible values of alpha is 4 by 5 whole square plus 4 square plus minus 4 whole square, which is equal to 16 plus 16 32. 32 plus 4 by 16 whole square is, that is 16 by 25. So 16 by 25, it's a decimal value, and the greatest integer value we want, the greatest integer less than or equals to p. So this is p here. So step value of p is equal to, since 16 upon 25 is decimal which is less than 1, so we can say 32 is the answer.